everybody doing? Having a good time tonight? All right. So before we get started on the next talk, I have one announcement to make. Next month is going to be Swapvember, aka SecKC's redistribution of crap month. So if you got, like all of us, you have a bunch of crap in your basement, electronics related or not, that hackers might be interested in, bring a box. You want to talk to Justin Ferguson. He is kind of leading up the whole thing. It's first come, first served basis. You bring a box of crap that you want to get rid of. Other people bring more crap they want to get rid of, and you get to trade your crap. So if that sounds like fun to you, that'll be next month. There are some other rules that go along with that, but go ahead and talk to Justin about how that plays out. But for right now, we have Andy, who is going to talk to us about injection attacks and show us actually how to fix those. So if you do any kind of software development work, you want to be perking your ears up and listening into what he's got to say. So without further ado, let's give him a round of applause. Woo!
It's muted. It was muted, probably.
Hello.
Good. I thought maybe I got rejected there at the last second. Okay, so I'm here, and my name's Andy Nelson. My talk is called Injection Attacks and Defending an Application Takedown. I've been a software developer for pretty much my entire career. I work at Cerner just like Kevin. It's kind of funny that we're both here tonight, but it's just the way it all fell out. So I've been doing some security work at Cerner for the last about a year and a half now. And so coming from the developer side of the world, it was a big difference to me doing security now versus kind of my perspective and my ideas on it beforehand. So we'll talk quickly about what SQL injection is. We'll look at what vulnerable code looks like. We'll go and exploit the vulnerable code, and then we'll do some other things with it as we get through here. So let's go ahead and get started with what SQL injection is. Most of you guys are probably already familiar with it. It's this big long definition that none of us actually care about or have time to read, right? We just go about and we say, hey, there's injection. Let's kind of look at it. So, but for those of you that maybe aren't familiar with what it is, I'm going to kind of give you a brief overview. It's really this idea of you've got this malicious code that you want to execute on the back end on a database, typically of a poorly designed web application or service. So there's an awesome XKCD image if you know what XKCD is. If you don't, you should probably start following it. It's pretty good. They have good cartoons regularly. But in this case, this one's pretty great because they named their kid Little Bobby Drop Tables. He went to school, and then the school dropped their tables because they put that into the system, and they didn't sanitize their data. And the parent says, well, you idiots, you should have sanitized your data. So you can go check out that XKCD and others as well. So for all of our kind of examples and stuff I'm going to show here tonight, I created a sample project, and at the end, I've got links out to all this stuff, including the slide deck, and you guys can see all that stuff. But for those of you that are familiar with databases, this will kind of look familiar. For those of you that aren't, this is a table in a database. Tables and databases are designed to hold information, and they're rows. In this case, it's going to be a MySQL database, and it's got rows of data. And so one row is represented by a username, a first name, a last name, email, all the information on this. If I want to go and get data off of that table, it's a domain-specific language called SQL, and I can go say select ID and common name from this users table where the username, or the name in this case, is Andy. And that would pull back all of the names that qualified, or sorry, all the rows that qualified with the name Andy. Now, what really is the heart of the talk is SQL injection, right? So if we go and append to the end of the SQL query, just this quick block that says or 1 equals 1, this is going to make this always evaluate to true. So this is what we're trying to do programmatically every time when you use a tool or you try to interact with somebody or some service or application and try to inject some code. You're trying to inject this true statement so you can start getting a bunch of junk out of their domain or out of their database. So let's quickly talk about why we care about this. So as a developer at heart, this is something that I care about regularly. I look at the OWASP top 10 list now, and this has been the top of the list for the last 3 times I published this, up until including last year even. There's this awesome website called the Hall of Shame. So they actually haven't had one of these that's been wildly public in several months now. I think May was the last one. But this website goes and categorize, or I think they categorize, yeah, they have a result of what got released, and it's got a date, and it's got the website that was breached, or the technology or whatever that was breached, and reference out to. And they've just got this catalog of all these sites that have been breached via SQL injection. Included in that list is big vendors that you would probably use regularly, and you've probably seen, including GoDaddy, WordPress, Equifax, McAfee, the US election, Belkin, Joomla. So it's not like these mistakes with SQL injection are being made by what I would call small, unimportant companies. I would say almost every one of us probably works for a company that's probably susceptible to this. And that's a problem. But let's look at why this is happening though. And this was interesting to me because, again, I'm a developer, and I started thinking about this, what's happening here? And we have all these developers, a lot of them are new graduates, some have been around for years, but in a lot of cases, people just don't read the code that they're gonna execute from an external third party or understand the APIs they're using. So if you're developing a Ruby on Rails application or a Go application or what have you, you may not go and read all the security documentation because it's long. Rails, Java, they've got big, long, in-depth security guides on these things, and they're not easy to follow in a lot of cases if you don't understand some of the terminology. But outside of that, there's this general lack of security focus in the developer world. And this is shocking to me coming to somewhere like this where I see all of you and all of everyone here that's excited about security. But on the development side, it's just commonplace that we're trying to get code out, we're trying to create new products, and that's the goal. And so we also have this lack of awareness that I don't know what I don't know, and up until I did this presentation, I really didn't know how to use malicious tools to go and perform a SQL injection attack. So
actually,
what's up?
Real quick.
Yeah.
So we have a little tradition here at SecKC. First time you give a talk.
This is my second time.
Whoa, somebody fucked up then, because you got a double right here that I was told to give to you, buddy.
I don't drink.
You and me both, dude.
We have a problem.
Well, first off, to everyone who thought this was his first time, this is awfully embarrassing for me, so fuck you. I guess carry on with the talk, and I've got 2 shots of Jaeger here, because I don't drink either.
Hey, Christian, you thirsty? Christian, you thirsty?
Well, yeah, who's that? Because he's pointing them out.
Christian, he's wearing the Mr. Punisher shirt right there, pointing at Kevin. This is great. Nobody drinks at SecKC apparently. Yeah, literally any one of you can have it. Yay! That was really loud, sorry. That's great. Thank you for taking it. Good job, whoever you are. It's so bright, you can't see anything over here. Okay, so back to where we were before I was so rudely interrupted. So let's take a look at a vulnerable project we've got here. So I wrote a vulnerable project in Rails. Here's a bit.ly link. I promise you I haven't done anything malicious. You can click this link, take it for what it's worth. If you don't trust this, you can go find me on GitHub directly. Just search for this project. What's that? Yeah, it's not a virus. You can go search me on GitHub directly. You can find it. This is just to make it easier for you to find. And then JavaRX, for Java with JaxRS, I didn't write any actual code around it, except for just code samples that I'll show in this project. So if we go back to this user table that I showed a little bit ago, we've got the same data we just talked about, and then I wrote a couple of endpoints. So an endpoint in development world is if you're going out to a website or you're going out to a service, and it's how you would access data about something. So in this case, we wrote these endpoints, 2 of them. I specifically called them injectable users and not injectable users. They do what they say they do. One allows for you to do a SQL injection attack against it, and one doesn't. As far as I know, anyways. I'm sure there's a way in, like anything, right? If I tell you there's not a way in, you're going to find a way in. But they're designed to use the secure APIs that Rails provides. And in this case, with injectable users, we just made username and first name injectable, so as parameters. So let's go look at this vulnerability. So we had some SQL, and you'll see this context is in the context of Rails. We had some SQL earlier we talked about where you do select from and get things and do whatnot, right? So in this case, we wrote our select statement. We've got our select, and then we've got our qualifier, In this case, our qualifier just says where the ID is equal to the ID that's passed to me. And why this is bad is because that data isn't sanitized. We didn't use any of the built-in Rails application code libraries in order to sanitize it, and we didn't do anything personally ourselves. We're literally just taking whatever the user provides to us and just dumping it right into a command and then sending it off to the database to execute. So, not sanitizing our input is a bad idea. Most of you guys that are doing penetration testing or things along that line, this is probably like the gem you're looking for every day when you go out and look for things, right? So if we look at how you would do another way of this in Rails, and this is a common mistake people make, is they say, oh, I'm using this other thing where I just pass the qualifier alone, where I say user.where, and that effectively hides the select part of your comment. And they're like, oh, I used the API, but this is something I found a lot, is that people think this actually safely sanitizes it, and it doesn't at all, because you're still just encapsulating and passing along unsanitized data. And there's numerous ways of going about and passing non-sanitized data, and there's, in this specific example, and you'll find lots of these in whatever language you're doing. In Rails specifically, if you go look at Rails SQLi, they talk about various methods and ways that you can go and exploit Rails code. And I found one of these that I was surprised by in the calculate method, and so I just kind of highlighted it here. It's not super critical, but I was just kind of shocked that it didn't sanitize it. And I would have never guessed that, and I developed, and I would have been like, oh, crap. So anyways, when we get back to the Java world, it's very similar. You've got this idea of a select statement, and we're just going to pass it along to get data back. And we've got our select, and then we've got our qualifier. So again, we didn't sanitize this data. It's just passing the ID right to our database. And so if you pass me whatever you want, then you're going to get whatever you ask for. So moving along, we're going to do a step-by-step kind of injection testing with some what I would call not so cool tools. So you're probably here to see like the cool way to do this. This is going to show you like the easy way, and so hopefully it'll make sense. And then we'll show you the tool. I use a little bit of my knowledge of things, and so in some cases, for all of you trying to do malicious things on the internet or even do penetration testing, if you've never heard of Swagger, a lot of REST APIs and things like that are all documented with Swagger, so you can find like the gold, the golden pot of whatever you want to go hit from Swagger. And so go and see if the API you're trying to hit has Swagger enabled, and if it does, you can just go find whatever you want. And then I use a tool called Postman that just effectively makes calls out to REST services and gets responses back. So in this case, what I want to do is I'm just running this application locally on my Mac here, and what I do is I hit localhost, which is just running locally. So I've got my host, and I've got my endpoint with injectable users. So this is kind of a basic explanation of how we would do that. We'll go through, and you'll see in Postman, this is Postman now. I've gone and put localhost 3000, and I gave it / injectable users, and I get back a bunch of data that I seeded into my database. And you can see there's 200 people that I put in here. It's all fake mock data. I used a Ruby library that generates all this for me. If I want to go get a single user, I can give it localhost. I give it the endpoint that I want, so injectable users, and then I can say ID equals 1, so for a query parameter, or first name equals Wilfred is a query parameter as well. And if we pass those all in that manner, using Postman again, we change in Postman we can go do this and say ID, and then we say equals 1, and then we give it plus or plus 1 equals 1, because we have to make it look like SQL when it gets to the back end. And this is how you're effectively going to make that happen, just manually typing things in your browser or using a tool like Postman. And this gets back all the users, even though we really only asked for ID equals 1, but we also said or 1 equals 1, which evaluates to true. So we can do the same thing with injection by first name. We've just got our host, endpoint, query parameter, and then our injected code. And then here you can see if we go and run that, hit send, and then it will respond whenever I click send. Sorry. Okay, yeah, so then we get back all that data. So this is how, when tools are doing this under the covers, this is what they're effectively doing. So this is pretty slow for a human to go do this, although you can find some really interesting stuff, and you can go and start looking at data and finding, where endpoints are vulnerable or applications are vulnerable. you're not going to find, everything very quickly because it just takes a long time, right? So let's go look at automated injection, because this is where you can start gathering everything really fast. And so for this case, I'm going to call this hacker tools, right? This is all of you hackers out there that come to this. I'm a developer, so I'm going to try and offend you as much as I can, but we're going to use these hacker tools because as a developer, I've never used these things before. And so I learned how to use SQL Map literally in like 30 seconds. Oh, sorry, I should have talked about that first. There's lots of these to pick from. Really what it comes down to, though, is the one that's most, the most code commits, the most active kind of community. It looked like SQL Map, to me, was the most active from that. So I picked it. And really the idea is that you can learn this thing really quickly. It's got a great console for penetration testing. I was surprised at how easy it was to use. It supported all the major databases that I'm going to use or that I could find for most people on the internet using. You can do enumeration of users. You've got various techniques that are supported between Boolean-based blind attacks and error-based attacks, union queries, and time-based, a whole various of those. It's pretty feature-rich. You can dump things out from the console. You can log into the console. You can do a lot of things. And it's really well maintained with great instructions. Really, this was the biggest thing to me. Coming to this world that I had never done this before, to be able to get started immediately and then just run with it was shocking and surprising to me. And really what came down to when I was talking to some other people about this talk was developers have no idea how easy these tools are to use in a lot of cases unless they come to things like this or they just have general interest. And so showing this off to other developers quickly became like my goal because I was surprised by them. So let's go and start attacking, right? We got this guy. Anybody know this guy? No. Yeah, sorry. Nobody laughed. Okay, that's fine. All right, so step one. So we want to find our target. In this case, we've already found our target because I showed it to you. So it's not that hard to find it in this case. But, so the goal of this talk isn't to show you how to find the targets, it's to show you how to exploit the targets. So if we got these targets, step two is to use SQL Map, surprisingly enough. So there's an option when you run SQL command or SQL Map from the console called SQL Map, and it's -u. -u will start attacking the URL that you give it. So in this case, we want to give localhost 3000, and then our injectable users, and then the query parameter that we want to start attacking. And so from here, we'll start doing some demos of things. And in this case, I've got my local terminal running that's running my application on the left-hand side for you guys. And on the right-hand side, I've got SQL Map, my console running SQL Map. So they're side by side. So you can see when I type SQL Map on the right, and I'm going to say, give it my endpoint, and I'm going to tell it some other parameters. Don't worry about those. Those are just so that it flushes my session to get rid of all the stuff that's cached. And then on the left, you'll see, as soon as I hit enter, on the next set of slides, you'll see the output report of this. And so when I hit enter, you're going to see really quickly that it's going to, on the right-hand screen, it's doing a bunch of SQL Map stuff, and on the left, it's all the access and console logging from my application. And what you'll see is it's doing a bunch of things, and it's testing for all these various versions of MySQL, and it's testing with different parameters, and it's reporting back things that you and I can't do in the 5 or 10 seconds that just took, right? And what happens is it reports back that it found a query parameter called ID that was susceptible to a Boolean-based blind attack, and it shows you the payload that it sent along in order to attack that endpoint. In this case, it said, again, Boolean-based blind being it was just a true or false attack, and then it passed 9428 equals 9428. It very easily could have passed 1 equals 1, but it is what it is. And what happened when it did its attack is on the left-hand side of the screen, it created the SQL query where that's a big, long SQL query that I can't create manually, and I'm sure most of you can't either. But this tool can, and it can do it really quickly in rapid succession against lots of different places. So these tools like this are super powerful and really terrifying to developers. So success, right? We got our stuff out, or we got a place where we can go and do what we want to do. So what do we do now, right? We've identified this injectable parameter, and so let's start exfiltrating that valuable data. This is a security researcher or a pen tester. This is the point you're looking to get to. Me as an application developer, this is the point I'm trying to prevent because this is where I get in trouble and our company gets in trouble. So what we want to do next, step 3, is find all the databases, because if we find all the databases, we can start targeting specific ones and saying like, what ones might have data that we care about. So there's a quick and easy command for this. It's --dbs, and it's just going to list all the databases as long as the session user has access or read access. And so what we're finding in the AppSec world too is it's not a matter of developing secure code, but it's also this matter of working with our system engineering groups and teams on the other side, in the operations teams, to make sure that our databases are locked down appropriately with the right access levels. I mean, you see escalation of privilege constantly when people say, oh, I just went on a box and I escalated my privileges. So this box didn't even have escalated privileges because I set it up, but if somebody can escalate privileges, then they're going to be able to get more information out of it. So we have our attack command you saw a second ago, and then we have this new option, --dbs. So if we go and change our console log, so now it's --dbs instead of that other stuff, you're going to see very similar on the right-hand side, except this time it kind of saved some of my session information, so it went a lot quicker, and it just reused the same Boolean-based blind attack, and it gave you a payload. And what it does, it printed out all the databases that I was using locally on my MySQL instance. So for testing and for purposes of this talk, I created a database called SecDB. Now, if you're a security researcher or somebody along that lines, you're going to see that, you're going to immediately want to get in there, right? Like that's the thing you want. So I want to display all the tables off this database. So you can see how quickly this can kind of scale in, and you can start getting a lot more information out just by passing new options built into this tool that take no time whatsoever to go run or investigate. And this time, it's -d and give it the database name and -- tables, and that's going to start printing out all the tables associated with that database. And so, as we run that command, you'll see it's going to do a bunch of stuff on the right, a bunch of stuff on the left again, and it's going to print out all the tables. So me as a Rails developer, I know really quickly what it's doing. And again, you can see it's doing the Boolean-based blind attack. Oh, it also found a time-based blind attack where it can just wait a small amount of time and it can do some other things. But in this case, I want to look at these tables, and I'm specifically as a Rails developer, I don't care about internal metadata or schema migrations, but users is a real table, and that's where we find things to log in as other people, right? So let's go take a look and see what this table has on it. And we can do that by saying, give me all the columns. And giving all the columns is just as simple as giving the table name and -- columns to print out all the columns on that table. And so, in doing so, just like we've seen previously, I'll run and change this command, and as we go down and it starts running, I clicked too much apparently, but we give it -t for users and -- columns. Now we see that same column listing, that same database schema that we saw earlier tonight on the first set of the slide, and now I'm seeing it in my console. And so me as somebody that's trying to attack this, I quickly know all of the information stored on this. And specifically, I've got an ID and an email, and I see password field. Now, these passwords in this database aren't necessarily encrypted or secure by any means, but we don't know that until we dump the data out, right? We don't know if that's true until we dump the data out. And so if we dump this data out, you can give it --dump. And again, same set of commands. In this case, I just want to dump out the username and the password. It's --dump. I get all that info out to my console yet again. And all of this is just accessing it from my local machine running halfway across the world to your service that's up and running. And you can see these I just randomly generated a bunch of character sets, so there's nothing to them, and it's all dummy data. But you could really quickly take this list if you had it and go run it against a set of rainbow tables, or whatever latest version of whatever the leaked, I don't know, probably Facebook trend, whatever the latest breach is, right? Start running stuff against the latest set of breach data and see what matches and see what you can go and get into. And so this is terrifying as a developer to see how quickly this was easy to get into. But even more so you got my data out, but I can also pop a SQL shell right here from my console running on my machine halfway across the world, just with this command --SQL shell. And so this is pretty intrusive because now I'm on the box and I can run other SQL commands. And so you can see I have a SQL shell, and now I can just run whatever SQL commands I want to. And then, once you have shell access one place, you can start thinking about how you're going to navigate everywhere else, right? So, and you can see again, it's running a whole bunch of stuff that you can't create and do on your own. So there's no way to really defend against like looking for, oh, if they just run this one thing, because there's a million things they're gonna run. But what happens, you know, is you and I look at this is that's awesome. Like that's an unbelievable amount of data to get really quickly without really doing much. As a developer, it's terrifying. So without going too much further into this, but like I said, you can go and pop shells and move different places, and I'm sure some of you that do this regularly have done this stuff before and probably can tell some awesome stories about this. I didn't go too much further down this rabbit hole because, frankly, for this talk, it's not super critical, but it looks really easy and it's pretty trivial. But where we're going to go next is we want to fix these vulnerabilities because we don't want our code to be susceptible to things that are as simple and trivial as this, and because it's one leak, one breach that goes out, and you hear from Kevin's talk, right? Even the 0 days that happen, your stock price drops. Sometimes you can recover, in some cases you can't, and nobody wants this to happen, right? So in Rails, it's really as simple as using prepared statements, but that's not just Rails either. It's really everywhere. So I advise, as I'm doing code reviews and I'm talking to people that work for me at Cerner, is we have to start thinking of more than just does the code function appropriately? Do we do the things that we're supposed to do to make this application functional? Are we kind of implementing secure coding practices and looking at how we should be doing security all along the lines? And in this case, again, it's really as simple as using these things called prepared statements, where you still see this command we did earlier where it's user.where, but instead of just passing the input directly, we use a more targeted API that allows us to sanitize the data, and this is what it looks like. In the Java world with JAX-RS, it's pretty similar as well. It's just this prepared statement, and I just realized I forgot to put the parameter. You guys probably didn't notice anyways, but I did. There's something that's missing at the end of there, but it doesn't make a difference. But it's still just, you have to know what you're doing and read the documentation and understand the security aspects of your code. So if we go and fix that thing, which I did with this endpoint not injectable, we've got this new endpoint, and we go rerun this thing again. It's pretty interesting because you'll see very quickly whoever's trying to access your system is going to be throwing this red flag, and I'm sure in a lot of cases, if you're looking for the simple targeted thing to attack, this is going to shut you down on this one, and you're going to move to the next thing. So this is where you kind of show this to developers, how easy it is to fix small, simple things and make sure that they get this instead of everything you get. Sadly, it's not a matter of just fixing one thing. It's usually a matter of fixing hundreds of things, but that's just how it goes. So as we look at action items, don't ignore that slide. Sorry, I should have taken that one out. I don't know why I didn't. It's specific to Cerner. So we've got some secure coding practices. So understanding the security of your technical stack, using prepared statements, code reviews, static code analysis, testing your application using SQL Map. I learned a lot just in doing this, and I was fairly surprised by it. I wouldn't have guessed that I didn't know all these things, that I could learn in a small handful of amount of time. And this kind of opened the gate for me to go look at other tools and try and get engaged and understand other things. So with that, that's all I have. If you guys have questions, come up, more than welcome to come up and ask. I've got my slides posted. I forgot to include the link here. But if you just go to my GitHub project there, you can go see that there, and then my Twitter handle. I'll post this off Twitter later tonight as well. I'll just tag SecKC. But my slides, I've got a link for that as well. So. But if you guys have any questions, I'll be here. You guys can come ask questions up here, or I guess if you guys want to ask questions in the crowd, that's fine too. Yeah.
I got a question.
Yeah, what's up? I just realized I'm the last presenter, so I can really stay up here until you guys leave.
All right, Key. All right. The question I have is, from your experience as being a developer, I've seen a trend with most vendors of going with an agile workflow, as far as they're more concerned about getting product out to the customers. So therefore, there's less time to do code reviews and et cetera, and a lot of developers that work in the field that have already been employed there or contracted are more concerned about getting the code out, and the QA has a week or so to do their testing or whatever, and then it's out in production and then out to the consumers. I mean, have you been in a scenario like that where you're in an agile environment, you only have so much amount of time to develop the code. You only have so much amount of time to QA it.
Yeah.
And then, in the end, the vulnerabilities are already out there, and you worry about hot fixes, et cetera, et cetera.
Yeah. So agile development is really it's not a good excuse not to do these things, but I can see where you're coming from, where people are going to claim they have less time. Security stuff at the end, you're probably doing that wrong anyways, maybe. So I'm not saying that's what you're doing, but if your developers are telling you that, then they're probably doing something wrong with their agile development. I can talk to you more about that later too if you want to, or you can hit me on Slack or on Twitter or whatever. So, yeah. But they're probably doing it wrong. Why are you laughing out there, all of you? Oh, our project manager is laughing at me. You said I'm glad I gave that answer. Is that what you said? Oh, good. Okay. Any other questions? Yeah, one right here. Oh, so he asked how do I launch my local application. So it's all documented on the README. I use Docker. If you're familiar with Docker, you can run it all via Docker. If you want to get a little more excited about it, you can install and run Ruby directly, whatever you want to. But it's all documented in the README on how to do that. So, Any other questions? All right. Thank you, guys.
All right, that wraps up the talks for the night. Hope you all had a good time. We can hang out officially till 9 o'clock, so hope you have a good night, and we'll see you next month. Or actually, yeah, next month. All right, cool.
Thank you. Yeah, it's
Right here. Right now. Right here. Right now.